What are you seeing now? All right. So hope every other person can see the screen. All right. So the last time we talked about transistor. So today we'll talk about relay and we'll repeat some of the circuit that we designed before. So we'll redesign them. We will redesign them, then add relay to the circuit. Because on the other circuit that we designed, we only added LED, which is a DC component. But now let's say we want to add an AC component, then maybe electric bulb, want to switch electric bulb on when you have darkness. Maybe you want to do maybe at 6 p.m. your light bulb or your security bulb should be on at 6 p.m. Then at 6 a.m. or maybe at 5 a.m. it should go off. So you need to you are not supposed to maybe you are using normal AC bulb. You are not supposed to be connecting it the way you connected the other circuit because the other circuit is DC. So you need something that will help you to isolate that DC from AC. So now relay is an electromagnetic switch. This particular relay, though we have some other types of relay, we have solid state relays, but most of the times the one you play around with, they are mostly electromagnetic switch or component, electromagnetic component that has basically 5 pins. I use the word basically because there are some relays that you have more than 5 pins. But the basic relay that we know around, that we can see around, they have 5 pins. I will explain further. Now, the 5 pins are coil. Two of the pins are coils. Why one is normally open, you have normally closed, and you have common. Those are the 5 pins. So as you can see on this diagram or this schematic representation of relay, this particular part is this place can be coil 1 or this place can be coil 1. So these are coil pins. They are not polarized, which means you don't have positive, you don't have negative, so anyone can go. So we have the common here, and we have normally closed here, and we have normally open here. So this is a 12 volt relay. Now relays are rated in relays of 12 volts. They can switch 220 volts, 220 volts, and 10 amps. You can see the ones that can switch 220 volts and 30 amps, 240 volts and 80 amps. So you have a lot of them. So once you want to use, you know the rating of what you want to switch, and you pick a relay that is directly proportional to the rating of what you want to do. So now we need to understand, before we can use relay to design a circuit, we need to understand how relay works. So before you can use a relay to design a circuit, first of all, you need to understand how the relay behaves. Now, at default, when you've not powered your relay, when you've not triggered your relay, the this is the common is attached to the normally closed. Just understand it this way. Once we start using it to simulate circuit, you understand better. But just understand that once you've not triggered your relay, the common and normally closed, they are together, they are touching each other. So they are in contact. But immediately you trigger your relay, what happens is that the common will leave the normally closed and it will touch normally open, as the name signifies, normally open and normally closed. So at default, you've not triggered your relay, normally closed is attached to the common. But once you trigger your relay, common will move from normally closed to normally open. Hope you guys are following. All right. All right. So now that's the working principle of relay. So we need to know how to trigger the relay. the mechanism and some other things you need to put in place when triggering the relay. Then we need to connect some other component around it so that we'll see how you can use it to design your circuit. Now we have different types of this solid state, sorry, this electromagnetic relay. We have basically two types. We have single pole, single throw, and we have double pole, double throw. So let me open simulation software so that I will show you guys what I mean by single pole, single throw, and double pole, double throw. So let me go to the component library. So these are the two major relays that we'll be using most times. Double pole, double through. Yeah, double pole, double through. That is this one. So which means you have double pole, and once you trigger the relay will also move. Those two poles, they will move together. So once you trigger your relay, these two common, you have common here, you have common here. So once you trigger your relay, those two will move together to normally open at a time. The same thing goes with this one. Once you trigger the relay, the common will also move out of normally open to normally close. So now I want us to draw a small circuit with these two relays. So let's start with this. Now we're going to be designing the circuit we designed the other time. We want to use LDR to monitor the light intensity. So once it's dark, the system should be able to turn on electric bulb, your normal AC bulb. And once you have enough illumination, the system should turn off the bulb. Hope you guys can hear me. All right, so now we need some components. We need LDR, light dependent resistor. We need normal resistor, and we need LED. So I will take red. Let me look for red. This is red. So now let me place the component the way it should appear. So I have my resistor here. I have the LDR. So I have the LDR. Yeah, that's true. I need transistor too. So I need a resistor here at the base of transistor. So this is the transistor. I want to make sure that it's connected properly. Okay. So now we are familiar with this particular circuit. So now I want to connect the relay here now. So now the reason why I'm including this transistor, naturally I would have connected my relay without transistor, but we need enough current for this relay. We are dealing with coil, so we need enough current. That's why we are including this relay. Yeah, and again we need to send signal. We cannot connect signal directly from maybe your, let's say you are using a microcontroller. You cannot connect signal from microcontroller directly to your what's it called now, relay. So you have to attach transistor to also amplify the current that will enter the coil. So you connect your relay here. I said initially that the relay is not polarized, so which means this part can also go to negative and this part can go to positive. Any part can go. So now you don't just connect your relay like this. You add transistor. Sorry, you add diode. You add diode. Okay, now once you turn off any circuit that has a coil or an inductor, once you turn it off, definitely there's going to be backflow of EMF. There's going to be backflow of EMF. So now you want to connect this diode so that once you turn off your device, the diode will block the backflow of the EMF. It will not flow back to your circuit and damage something. So that's why we are attaching this diode here. Observe the way I'm connecting it. You observe that the negative part of the diode is connected to positive. So you should observe that while also designing your own circuit. So I have hope you guys can still hear me. All right, so now as you can see here, all right, so as you can see here, this is 12-volt relay. So you should also make sure that your power is 12-volt too. So here I'll double click here, or you right click and go to edit properties. Then you choose the appropriate power or you input the appropriate voltage. So enter. So I have 12-volt there. So now I need a light bulb. So I'll go back to the library. I'll bring out bulb. So lamp, I'll bring lamp. Then I also need V sign. V sign is used to represent AC voltage. V sign is used to represent AC voltage. So this is my lamp. So I will connect this and I will explain why I'm connecting it this way. So this is rated 12 volts. So I will go here to my frequency should be 50 Hz. Then my amplitude should be 12 since this guy is 12 volts. So now looking at this circuit now, remember I told you guys that once you trigger this relay, this is common, this particular pin now, this particular pin is common. It will move away from this normally close to normally open. So now naturally this is our lamp, and for your AC lamp, before AC lamp will come on, you need to provide both neutral and live. So that's why you're using your manual switch at home to connect. Naturally the live has been connected to the bulb. So what you have to do now is to close the neutral too. So you're using your switch to close the neutral. You're using your switch to close the neutral. So but now we want to use this relay to close it. So what will happen is that once you trigger this relay, this common will move away from this normally close, it will go to normally open, and this normally open has already been connected to the other part of your bulb. And looking at this side, this other part of AC was also connected to this part. So this is constant, this part is constant. What we need is for this part to be complete now, so that this bulb will light on. So once you trigger your relay, this other part will be connected immediately and your bulb will come on. I don't know if this explanation is clear. Is it clear? Or you have any question for everybody? Okay. As I said before now, you once you have a coil in a circuit and you turn off the circuit, immediately you turn it off, there will be a backflow of EMF. So the reason why we are connecting these diodes is that we don't want, once we turn off our diode, something will now spike or something will happen and it will go back to our circuit and damage our circuit. So we want to add this diode so that when that happens, this diode will block the flow so that it will not flow back to our circuit. Yeah, so I want to simulate the circuit now. So I'll play. So the circuit is on. Hope we can see the circuit very clearly. All right. So now I want you to keep your eye on this particular common rather. So I want to bring close. I want to remove the touch because the touch is signifying that we have enough illumination. So I will go back. Immediately I went back. Can you see that the light is on now? This guy moved from here to here. Did you observe that? Did anyone observe that? Can I want to make sure that all of us are following. All right. So let me increase this value so that let me take this value. Let me say 20k. Let me say 20k. So keep your eye on this normally open. Sorry, the common. So I want to go back. I'm going back. So as you can see, the common has shifted from normally open to normally close, and our bulb is lighting. The bulb is lighting. So if I go forward now, it means the illumination is increasing, and as you can see, the common has also fallen back to the normally close. So that's how you use relay in your circuit. You want the street light to illuminate the place when someone is passing at night. So how do you do that using this circuit? How do you reconfigure or redesign this circuit to accommodate that so that your your LDR for dictating whether it's day or night, and also you have your motion sensor for sensing whether there is presence of human being. If there is no presence of human being, the light can be dim or maybe the light can be entirely off since till someone comes around before it to come on. So how do we go about that?